So there are going to be three possible areas in mixtures. One is replacement. Okay. Standard question, but if you don't know this, you will end up wasting too much time. What a replacement question does is that the same proportion is getting removed and then replaced with the other liquid every time. So you have a mixture of two liquids, A and B. Some proportion is removed from here, and then B is entirely put here. So then your answer will look to be something like this. The modifications to this we will shortly discuss. The second area is key movements, and this is where the bulk of your questions will lie. When there are complicated mixture scenarios with multiple steps, combination of removal, addition, or unequal replacement, most of your lengthier mixture questions are actually from this key movements area. So this is one of those scenarios where in time and work, TSD, ratio proportion, we were able to organize the data and our thoughts and our execution in a much better manner when we organized our information through table or line diagram. So this is going to be the number one suggestion for you. If it's not a replacement question, it is probably a key movements question, in which case you should make a table or a line diagram. Allegations, again, I have already explained that to you. It is something which is applicable only when you have two solutions that are getting mixed. It is fast, but it generally gets applied in a one step scenario. You have one mixture, you have another mixture, you mix them, there is a third mixture, find the concentration of this third mixture. There is no, something is removed from here and put here, then it is getting added back, something new is getting added back. That becomes your key movement question. So these are the only two shortcuts that you have available here. Other than that, you will have to, face the music, so to speak. You will have to actually go through the hard work to find the answers. So in replacement, same proportion is getting removed every time. So the standard format is V final is equal to V initial into 1 minus the proportion that is getting removed and replaced every time raised to the power n, where n tells you the steps that have been taken. So a short table, which again I have asked you guys to make many times, but if you have not, so let us see it here. Let's say that the initial volume is V naught. X amount is replaced, and this V naught is completely your milk. Let's say it is milk. Now, out of this, X is removed and replaced with water. So, in the first step, you now have V naught minus X milk, corresponding to which you will have X amount of water. So, if I say, can I say that V1, you know, your volume after first step is your initial volume into 1 minus X by V naught raised to the power 1. So far, this expression is holding. Now, let's say that X amount is again removed from this mixture. What is going to be the milk now? Now, the X amount that is getting removed, it is going to get removed from both of these, milk and water, in proportionate quantities. What is the proportion of milk for step 2? V naught minus X divided by V naught minus X plus X. The volume of milk divided by total volume. This is the proportion of milk, and this is X by V naught is going to be the proportion of water. So how much milk will get removed in this step? This proportion into X. This much milk has been removed in the second step. So how much milk will remain? Initial, which is V naught minus X, minus this much that is removed. It will get added to water. I'm not concerned with water, which means your V2 is going to be what? V naught minus X minus V naught minus X by V naught into X. So can I take V naught minus X common here? V naught minus X I took common. This becomes 1 minus X by V naught, 1 minus X by V naught. And if I again take V naught common from here, I will get this 1 minus X by V naught into 1 minus X by V naught, which becomes V2 is equal to V naught times 1 minus X by V naught whole square. After this step, I'm not solving. After this, this entire idea will remain. If you have different proportions getting removed and replaced. Let's say x amount replaced in the first step, then 2x amount replaced in the second step. Your amount will look like v2 is equal to v naught into 1 minus x by v naught into 1 minus 2x by v naught. And this should look something like percentage successive change graph to you. Yes, all right. So this is all that you have to do in these sort of questions. Glass filled with milk, two-thirds of its content is poured out and replaced with water. If this process of pouring out two-thirds of content and replacing with water is repeated three more times. So initial volume, let's say, is V naught. Two-thirds of the content is replaced. So V naught into 1 minus how much? 2 by 3. What should be the power? Poured out and replaced with water. This is step 1. Then repeat it three more times. So power 4. So your volume of milk is going to be V naught by 81, which means volume of water is going to be what? 80 V naught by 81, which means milk to water ratio is going to be what? 1 is to 80. In this particular situation, a lot of people make this mistake. You got the proportion of milk and you write this as the answer. They are not asking you for milk to total ratio. They are asking you for milk to water ratio. Average mixtures questions, guys, please once read what they are asking you for. Otherwise, even after doing everything, this question is done in 30 seconds, right? But, it's no point. This is 30 seconds and securing -1 marks. All right, next question. P is formed by removing a certain amount of coffee from a coffee jar and replacing the same amount with cocoa powder. Same amount is again removed from mixture P and replaced with same amount of cocoa powder to form a new mixture Q. If the ratio of coffee and cocoa in the mixture Q is 16 is to 9, then the ratio of cocoa in mixture P to that in ratio Q. So they've tried to complicate this because CAT 2023, but we are not going to get intimidated. So they are saying that 16 is to 9 is the coffee to cocoa ratio in mixture Q, which is made after second two iterations. So coffee to total total is going to be 16 by 25, which means initial coffee, let's call v naught, into 1 minus whatever proportion is getting removed, let's say x whole square, is equal to 16 v naught by 25. This will give you x is equal to 1 minus x is equal to 4 by 5, or x is equal to 1 by 5, correct? So 1 by 5 proportion is getting removed every time. Now you have to find what? Ratio of cocoa in mixture P. So P is after one iteration. What is the coffee in mixture P? V naught into 1 minus 1 by 5, which is going to be 4 V naught by 5, which means V naught by 5 is going to be the cocoa in mixture P. What will be the cocoa in mixture Q? It's going to be what? 9 by 25. It's already given to us. Coffee to cocoa is 16 to 9, which means uh, cocoa to total is 9 by 25. So 9 V naught by 25 is going to be cocoa in mixture Q. They're asking us for this ratio. It's going to be what? 5 is to 9. So again, same application, but they just had to complicate it because it was 2023. Container has 40 liters of milk, 4 liters removed from container, replaced with 4 liters of water. Okay. This process of replacing 4 liter is continuously repeated. So your final milk after nth step is going to look like 40 into 4 liter is replaced from a 40-liter container. So 10% is getting removed. So 1 minus 1 by 10, or 9 by 10 raised to the power n, the smallest number of times of doing this process, after which milk in the container becomes less than that of water. So you want milk to be less than water or less than 20. So, or you want 9 by 10 to the power n to be less than 1 by 2. Right now, this is one of those situations where I had told you that uh, even though they have not given you anything here, you will have to estimate this value of n. Maybe knowing log values of log 2, log 3 and log 5 would have helped you here, because you could have just taken log here. So please memorize these three. It's going to get used. It can get used in inequalities like this. This is a concept that after how many steps, you have already seen many times. If you are using calculator, you can, let's say 9 square is 81, then you skip 9 cube, you directly square this and arrive at 9 to the power 4. Then you can skip 5 6 7 and directly arrive at 9 to the power 8 as 9 to the power 4 whole square. So it's up to you how you proceed with this. Now, for key movements, make the table, make the line diagram. That is the best advice that you have for this particular situation. What you look for here is that your final concentration for anything is going to be your desired liquid divided by total volume. And this desired liquid is something that you can, you will probably get as, some addition, subtraction, combination of previous steps that would be involved here. And this is how you will find the final concentration. So you should be focused on the numerator and the denominator. So if I go ahead with this question, vessel contains a certain amount of solution of acid and water. 2 liters of water was added to it. The new solution had 50% acid concentration. So let's say the initial volume was A. All right. Uh, and 2 liters of volume water was added, so the volume become A plus 2, which had 50% acid concentration. So A by 2 plus 1, right? This is the acid uh, after one step, correct? Which means in the initial A also, A by 2 plus 1 would have been the acid, which means water would have been A by 2 minus 1. So this is acid, this is water. All right. So all that you have to find, because they're asking you for ratio of water and acid in the original solution, you need to find the value of A. All right. Now in this solution, 15 liter of acid was further added to this new solution. The final solution had 80% acid concentration. So let's find the denominator. What is the total volume? A plus 2 plus 15, that is A plus 17. Correct. What is the desired volume? I want the volume of acid. So I had A by 2 plus 1 initially, then I added 2, which was your water, so it is of no use. Then proper 15 liters of pure acid. This is equal to 80%. This is a linear equation. You get the value of A and then you find this water and acid, and you will get your answer as 3 by 5 for this. Similarly, a certain amount of water was poured into a 300-liter container, and the remaining portion of the container was filled with milk. So let's say X amount of water was poured. So you had 300 minus X milk. Okay. Then an amount of this solution was taken out from the container, which was twice the volume of water that was earlier poured into it, and water was poured to refill the container again. So now 2x amount has been removed from this, right? How much milk will go away in this 2x amount? 300 minus x divided by 300, which is the proportion of milk in this container, into proportion is going to be what? A ratio, a percentage. How much percentage of what? 2x, because you remove 2x amount. This much milk has been removed, which means how much milk is remaining? 300 minus x minus this. Initial was this much is removed, which will give you your final milk remaining, which is your numerator. Your denominator is going to be 300 only, because rest is supplied with water, so the container is filled back to the top. This is given to you as 72 by 100. This is going to form a quadratic. Once you solve the quadratic, you will get two values of x, I think 420 and 30. And because the container volume is only 300, you can't have 420-liter milk. So your answer will turn out to be 30. So my entire focus was on finding how much milk is remaining, and then I will write this numerator and denominator thing. So until you have this clarity that I have to do this numerator by denominator thing, things will, tend to get messy. Next question. Two containers of same volume. First container half filled with sugar syrup and second container half filled with milk. So what I usually do in these sort of questions is I will write a table C1, C2, and you have sugar and milk. Correct. They have the same volume. So let me say this is V or V, or you can also say that you can assume some volume also, because the ratio, the final answer is going to be a ratio. So let's take 1000 and 1000. All right. So first is filled, half filled with sugar. So you have 500 ml of sugar and you have 500 ml of milk in the second container. This is the situation initially. Now what has happened in the second step? Half the container of first container is transferred to the second container, which means you have 250 sugar remaining here. 250 transferred to C2 and 500 remains as it is. Then half of this mixture is transferred back to the first container. Now because you are transferring half, you know, because they have not said that 100 grams has been transferred or 200 grams has been transferred, they have given you the ratio of what has been transferred. uh, this half will be half of this and half of this. This half will be taken from both, which means your C1 will become C1 and C2. So 250's half will go away, which is 125. So this becomes 375 and this becomes 125. And similarly, half of water will also go away. Half of milk will also go away. So this becomes 250 and this becomes 250. Next, half of the content of the first container is transferred back to the second container. So half of 375 is transferred back. So this becomes what? 80 5 gives you 370. So 187.5, correct? And this becomes what? 187.5 plus 125, which is going to be 312.5. I hope. And this also gets halved. So 125 and this becomes 375. Ratio of sugar, syrup, and milk in the second container. So you want to find the ratio of this. 312.5 is to 375. Correct? So you can then find this ratio. You can divide by 12.5. It's going to divide all of these numbers. So and then you can find your answer from here. Okay, so you have to make this sequential table, otherwise it's going to get messy. A glass contains 500 ml of milk and a cup contains 500 ml of water. So same I will do, C1 and C2, or I can write this as glass and container. So milk and water, 500 milk in glass and 500 water in cup. From the glass, 150 ml is transferred to the cup. So this becomes what? 350 and this becomes 150 and this is 500 itself. Now 150 ml of this mixture is transferred from the cup to the glass. Now 150 ml is going to get transferred. How much is going to be removed? Now milk to water ratio. Now what is milk to total proportion? 3 is to 13 and water to total proportion is 10 is to 13. Correct? So glass and cup, 150 minus 150 into 3 by 13. This much milk is going to get removed from cup and going to get added here. All right. You have 500 initial in cup and 150 ml into 10 by 13. This much will be removed from here. This gets added here. What are they asking us for? Amount of water in the glass and the amount of milk in the cup. So amount of water in the glass and amount of milk in the cup, both of these quantities are actually the one and the same thing, that is 1 is to 1. Yes. So you would have seen that in the previous question we had 1, 2, 3, 4 pivots. Here we had 1, 2, 3. The reason being that in the first question, in this particular question, we had the proportion fixed as 1 by 2. So I only had to do half of this getting transferred and half of this getting transferred. In this particular question, in the second one, the proportions were not fixed. They had given the information to you in terms of volume. So extending this further would have meant too much calculations, and which, because this is 2022, not 2023, they were very off. Okay. So you are clear on this, how to deal with mixtures questions. I've taken two examples of your tabular format and two examples of a proper word format with multiple, steps that are there. Yes. Okay. Replacement again we are clear on. So let's just finally look at your allegations part. Applicable when two solutions are mixed. So what happens is if you have an average A1 of n1 items and average a2 of n2 items, and I say if I mix them, my average becomes a n, then or let's say a final af, then what I'm really saying is that the sum of the negative gaps has to be equal to sum of the positive gaps, which means af minus a1, which is this gap is shown by how many people, n1, should be equal to this gap a2 minus af, which is shown by n2 people. Obviously, you could have directly written this as weighted average also. N1 into A1 plus N2 into A2 divided by N1 plus N2. This is going to be AF. You could have directly written this also. And for the longest time, I only did this. It's just that when these gaps are very clearly given to you, it makes more sense to actually use N1 and N2 allegations. Otherwise, I don't really see a need. So I will show you. This is all allegations is equating negative difference to positive difference. Anil mixes cocoa with sugar in 3 is to 2 to prepare mixtures. Okay, one more thing. Generally, for you in mixtures questions, percentage would be a a trigger point to think about this allegations, because they have to give you the average and they have to give it to you in a format where you are easily able to deal with it. So that format would be percentage. Instead of saying average is 1 by 2 or 1 by 4, they would prefer to say 50%. If not, you can always convert it into percentage. It's much more easier to deal with. So let's say Anil mixes cocoa with sugar in the ratio 3 is to 2. So mixture A has, let's first see what they're talking about. Percentage of sugar. So we are concerned with sugar, right? So A has 40% sugar. B has 3 by 10, 30% sugar. These are combined in a 2 is to 3 ratio. Now, what you could have done is directly written the weighted average. These are what? These are the weights. So 2 into 40%, thus 3 into 30% divided by sum of the weights. This should give me the concentration in this mixture C, which would be 120 plus, 80 plus 90, that is 170 divided by 5 or 34%. You could have also arrived at this value like this. Uh, let's say this is my average x, so 40% minus x, which is being showed by two people, is equal to x minus 30%, which is shown by three people, and then you would have rearranged this and arrived at this same particular expression. So might as well write it directly. So weighted average seems to be the better option. Now once you have this 34%, he mixes C with an equal amount of milk to make a drink. So if you add the same amount of volume to something, are you essentially diluting it by half? After this, you can take the volumes and write that 100 ml had 34 ml of sugar, and now he added 100 ml of milk also, so total volume became 200, and 34 is the coffee sugar in that. So 34 by 200 is equal to your 17% is your answer. You could directly say that you have diluted it by half, so 34% will become 17%. Avoid this calculation. So answer for this question becomes 17%. Lemon juice and sugar syrup in equal proportion. So you have 50% of what, let's see, it is the same thing. They're asking us for ratio of lemon to sugar in the new mixture. So let's say this is 50% lemon solution. A new mixture is created by adding this mixture and uh, sugar syrup in the ratio of 1 is to 3. All right. So uh, let's instead use sugar here, 50% sugar, because the mixture that I'm making is with sugar. So let's say you have 100% sugar solution. I'm mixing these two in 1 is to 3 ratio. Now I might feel the need to do it by allegations, but again you will arrive at the same expression. So just write it 50% sugar into 1 plus 100% sugar into 3, uh, divided by uh, 1 plus 3, that is 4. which will turn out to what? 300, 350 by 4, right? Which is 80. Uh, 350 by 4 is not going to be 75. It's going to be 80, 7.5. So you have 87.5% sugar, which means lemon is what? 12.5%. What are they asking us for? Ratio of lemon and sugar. So 12.5 is to 87.5, which is 1 is to 7. Strength of an indigo solution is equal to amount of indigo. Okay, don't define. I know this. 280 cc bottles are filled with indigo solutions of strength 33% and 17%. So there is 17%, there is 33%. Okay. A part of solution from the first bottle is thrown away and replaced by an equal volume of the solution from the second bottle. All right. If the strength of the indigo solution in the first bottle has now changed to 21, so some volume of 17% was mixed with some volume of 33%, which became 21%. So this gap is 4 and this gap is 12, which means that the volume of 17% solution, let's say this is V1 and this is V2. So V1 into 4 should be equal to V2 into 12, or V1 is equal to 3 times V2. Now the total volume is something that is given to you. V1 plus V2 is given to you as what? The total volume of the bottle, right? So you can get V1 here as 600 and V2 here as 200. Yeah, so I mean, we got V1 as 600, right? Which means V1 is the volume that is getting transferred from the second bottle. So it is going to be 800 minus 600 is going to be your answer. I should have taken this as V2 and V1 and avoided this confusion. All right, clear on this. This is probably the only clean application of allegations. Directly you are able to find the ratio of volumes. So just to summarize, your allegations is a useful tool when you have been given all the three averages and you have to find the ratio in which they were mixed. But if you are given this average and the corresponding volumes, then using allegations to find the final average is it's a redundant step, because after you rearrange your allegation equation you will arrive at the weighted average equation which you could have directly written.